We all want our AI to be brilliant, right? We want it to find the exact answer we're looking for, buried somewhere in mountains of documents. But let's be honest, sometimes it feels like the AI is just guessing, like it's just going off of vibes. Well, today, we're going to look at a new way to do things that helps our AI think less like a fuzzy search engine and a lot more like a human researcher.
I absolutely love this term from the source article, vibe retrieval. It just nails it, doesn't it? It perfectly describes how traditional AI search sometimes feels. It finds stuff that's semantically similar, things that have the same general vibe, but not always the thing that's logically correct. And that's a huge difference.
So you really have to ask yourself this question. When you're using a popular technique like retrieval augmented generation or RAG to search through these really complex documents, is the AI truly getting the structure and the context? Or is it just making a really, really good guess? This is the exact problem we are going to unpack today. All right, so let's dig into the challenges with the standard way of doing things, what we've been calling traditional vector-based RAG. This right here lays out all the typical headaches. First off, you have to do this thing called chunking, which basically means chopping up your documents into little pieces. The problem? Well, you can easily slice an important idea right in half, splitting context across two different chunks. Then, you have to generate these things called embeddings and manage them in a big, complicated vector database. It just adds this whole other layer of heavy infrastructure. It's a powerful approach for sure, but it's not always precise. But what if there was another way? A way that actually mimics how we as humans find information in a book or a user manual. And that brings us to this really cool new idea, vectorless reasoning. And here is the absolute key difference. Vectorless RAG just completely ditches the whole vector similarity search thing. Instead, it uses the document's own built-in structure. Its chapters, its sections, its headings, and lets a large language model use its reasoning power to navigate that structure to find the answer, just like we would. This is the best way to picture it. Seriously, think about how you look for something in a huge technical manual. You're not going to read every single word from start to finish, right? No way. You'd look at the table of contents, you'd find the chapter that seems right, you'd skim the headings in that chapter, and then you'd read the exact paragraph you need. That is precisely what this approach teaches the AI to do. It's so intuitive. So you can see how this just flips the script on all those problems we mentioned earlier. No vector database, that means way less infrastructure to manage. No document chunking, your context stays perfectly intact. The retrieval process itself is much more human-like. And here's a big one. Because it's based on the LLM reasoning through the document structure, you get way better explainability. You can literally trace the AI's thought process step by step. Okay, this all sounds great in theory, but how do you actually build it? Let's roll up our sleeves and walk through the high-level steps to get this thing up and running. The secret sauce behind all of this is a fantastic open-source framework called PageIndex. Its whole job is to take a document and map it out into a hierarchical tree, kind of like a super detailed interactive table of contents. This tree is the roadmap that the LLM is going to follow. And here's the playbook. It's actually more straightforward than you might think. Step 1, you just install the PageIndex library. Super simple. Step 2, you set up your LLM, like Azure OpenAI, which really just means plugging in your API keys. Now for the magic. In step 3, you run PageIndex on your document, and it generates that hierarchical page tree we were talking about. This gives the AI its map. From there, in step 4, you just tell the LLM to search that tree using its reasoning skills, navigating down from big branches to the tiny little leaves it needs. This lets you retrieve the exact chunks of content, and you can even review the LLM's reasoning path to see how it got there. And finally, you generate your super accurate context-aware answer. It's a clean, traceable workflow from start to finish. So this brings us to the million-dollar question. When do you stick with the classic vector approach, and when is this new vectorless method the right tool for the job? It's not about one being flat out better than the other. It's about picking the right tool for your specific project. You're going to want to stick with traditional vector RAG when you're dealing with a huge pile of totally separate, unstructured documents. Think about a general-purpose chatbot for a website. In that case, vibe retrieval is probably good enough, and you need that blazing fast speed across a massive data set. Vector RAG is still your go-to there. But, and this is a huge but, if you are working with documents that have a clear, logical, hierarchical structure, This is where Vectorless RAG is an absolute game changer. We're talking about things like legal contracts, dense financial reports, or complex technical manuals. When you need the AI to logically connect ideas across different sections and getting the answer exactly right is non-negotiable, this approach really, really shines. So where does this all lead? Is it some kind of battle to the death between vector and vectorless? Nope, not at all. The future is almost certainly a smart combination of both. This is really the most powerful path forward, especially for enterprise AI. Just imagine a system that first uses the wide net of vector search to quickly find a handful of potentially relevant documents, and then it deploys this vectorless reasoning to act like a surgeon, precisely navigating inside those documents to find the exact, logically perfect answer. You get the best of both worlds, speed and precision. Ultimately, this is the big takeaway. We're actually shifting the goalposts. It's not good enough anymore for information to just have the right vibe. We need to build AI that can understand logic, structure, and context to deliver answers with pinpoint accuracy and a clear, explainable path. So, that leaves us with this final, exciting question. As we start combining the massive scale of vector search with the surgical precision of reasoning, are we on the brink of creating AI systems that don't just retrieve information, but actually understand it? It's a pretty amazing thought to end on.